Okay, good day. The next coefficient or wind coefficient we need to discuss is the topographic factors or the effect of the topography on which you will construct your structure or the building. So ASCE 7-16 and NSCP 2015 uh, discusses on how does the topography of the terrain or the topography of on which your structure would be constructed has an effect on the wind loading. So there is a term that we call the speed up effect. So when your building or your structure is on top of a escarpment or a ridge or top of the hill or top of the plateau, there is a phenomenon in which there is a wind speed up. So what is this topographic effects? So this was discussed by ASCE 7-16, and this is they consider it as something as a factor. So since it is a factor, it would amplify your wind loading. So as you can see here, if there is an effect of topography like I said earlier that your structure or your building is constructed on top of escarpment or top of a plateau or top of a hill or burol, talampas like that or a ridge, there is an additional factors like K1, K2, and K3. So, but interestingly, ASCE 7-16 has created conditions in which we consider this K1, K2, and K3. But if it does not met the criteria or condition of having a speed up effect on wind, KZT is considered as one only. So for this lecture, we shall have an example on how we can have this on how we can have the effect of topography. Ah. But first, let us try to see what does conditions no to consider the speed up effects or to consider the additional K1, K2, and K3. So first, the very first condition is that the ridge, hill, or escarpment in which the structure should be constructed should have been isolated for almost 3.22 kilometers or 100 times the h, or h means the height of the escarpment hill or ridge. So but first, what is this ridge, hill, or escarpment? So you can see here, this is a simple 2D diagram of ASCE 7-16. This is what we call escarpment. So this is a plateau, like example. It's not necessarily a plateau, but anything that look like this one. So this is what we call a escarpment. No? So this is a escarpment, and this is a ridge. So if your structure is if your building is constructed on top of this escarpment, then you consider the topographic effects as long as it meets the conditions. So example like this one, this is a building constructed in a top of the ridge, so or axisymmetrical hill, so escarpment. So for the purpose of this, the example is for escarpment. So okay. So conditions, no? So like the first condition that we have discussed, the escarpment, ridge, or hill should be isolated for almost 3.22 kilometers. And also, the escarpment or the hill or ridge should protrude above any upwind terrain by at least a factor of 2 within 3.22 kilometer radius, meaning this escarpment should have a crest or peak that is higher than the upwind terrain. So what is upwind? So upwind is anything that is in contradict with the direction of the wind. So from the meaning upstream and downstream. So upstream meaning it contradicts with the stream of the wind, and downstream means that the direction of that is the same with the direction of the wind. So upwind means contradicting, downwind means along with the wind. So that is the meaning of upwind. No? So as you can see in the upwind terrain, at least the protrusion of the hill or escarpment is having a factor of 2. So next, the building is located near the crest. So the crest and the peak or the mid height should have a lesser distance, or the upper one half of ridge hills should be lower, no? Sorry. Should the mid height of the escarpment, if it is escarpment, uh, or the crest, sorry, it's crest, no? So the crest and the building should have been nearer, or the building is located near the crest. So for the ridge, at least the upper one half is where the building is located. Okay. So next, also the quantity h, no? So what is this though? So the quantity h over LH should be greater than 0.2. So h is the height of the escarpment or ridge or the hill, and L over H, LH, sorry. LH is the distance between the foot of the, no, sorry, it's not the foot. The mid height of the escarpment or ridge to the peak or the crest. So peak or the crest meaning the uppermost, or the topmost, or the peak of the hill, the ridge or the escarpment. And the mid height is just the average between the foot of the hills or the escarpment or the ridge and the crest. So peak plus the footing, or the peak plus the foot over 2. That is the mid height, or that is the altitude of the mid height. So the distance between the mid height and the crest, that is LH. So that is LH. So it must satisfy that this must be greater than zero point 0.2. If it does not greater than zero point 0.2, although these three are met, then don't consider speed up effects. So just consider that KZT is 1.0. Also, the last one is the 5. Number 5 is the H, or the height of the ridge hill is greater than 18 meter for exposure B and greater than 4.5 meter from exposure C and D. So uh, let's try if our example have these conditions, no? But first, okay, so let's go to ano. So these are the, no, so like for example, let's say this one. Okay, as you can see here, the peak is 1,403 meters, or the altitude or the height, yes, the height h is 1,403 meters. And the upwind terrain is just 687 meters within a 3.20 kilometer area. So it satisfies 2, because 1,403 divided by 687 is a greater factor of 2 and within its radius. So I consider this part near Mount Sinaka, meaning this is the Arakan municipality of Arakan, and this is Davao. Uh, this is Davao area, Davao City, which is the Davao City area is the Marilog district, and this is the Arakan, and this is Davao. So as you can see here, it satisfy number 2. Also, it satisfy also number 1, because as you can see, it is isolated. This Mount Sinaka is isolated, and it satisfies number 5, in which the H is 1,403, or compared to the foot. So the foot is 687, or let's say later we have a foot that is 900, I think. So it's still greater than 18 meters or 4.5 meters. So let's try if H over LH is greater than zero point 0.2. So we can see that in an example. So let's try that. We construct it here, near here. Our building is constructed here. So I think it also satisfies number 3. So what is number 3? I forgot number 3. So the building is located near the crest of an escarpment. So let's try that if this considered. But if it is not considered, then consider your topographic factor, or KZT, as 1.0. But for the purpose of this lecture, so that you may know when to apply the provisions of this one. So when to apply these provisions. Okay. So for calculation, because this is an important input, this is a very important input because it affects how your wind loading, and because ridge, hill, and escarpment will really contribute, no? Because as you can see, instead of 1.0 only as the factor, it will be amplified by k by this one, no? So it will be amplified by this 3. So it will be amplified by this 3. So meaning we have higher loading and wind load. So don't forget to consider these topographic effects. So let's try an example here. So we have an example that the location of the building is 1,337 meters. And if we make this a reference, this is from 0. So this is the start of our of the our distancing. But as you can see, I use Google Earth and it considers 2.64 kilometers from this part. No? So building location is an altitude 1,337. So the crest is here. It's 1,403. Then the location of the building to the crest is 600 meters. No, I think this is near. This is still near for this one. But let's try. Let's try to consider for the for this academic purposes only. No. Then the footing is, you can consider footing the lowest, or the, yes, the lowest part of this profile. So this is the elevation profile. It's considered as 972 meters. As you can see here, it's 972 meters, and located 90 meters from the, I think, no, but we consider the location of the building as the reference point as the 0 kilometer. So the location is negative 2,550 meters. Uh, and lastly, the mid height. So computation of mid height is just finding the average between the peak, the altitude of the peak, and the foot. So the average of them is 1,187. So 1,403 for the crest altitude and 972 for the, what do you call that? For the foot, of the hill or the escarpment. So let's try this one as an escarpment, because as you can see, if you compare the picture here, uh, as you can see, it's like escarpment, no? It's like escarpment. So let's try this one as escarpment. So it's still your judgment of what is this, but as you can see, um, the elevation here is like escarpment, no? It's not ridge, because as you can see here, it's still continuing, or it's like escarpment. So, can see here, this is our location, the star, location of the building, the star, circle is the peak, the mid height is here, and the foot is here. So I have gathered the necessary data, and I have this one in, what do you call this one? Excel. But let's try this one in this first. So first, as you can see, no, the building is located in downwind part. So if our building is located here part, this is, we consider it as an upwind, but our building is located here. So it's in the back of the peak when the wind is considered here. So if the wind is considered here, then downwind and upwind will reversed. So if the wind is here in the from the right direction, then we don't consider downwind, we consider upwind. But when we consider wind here, like this one, so that it conforms with the, what do you call that? It conforms with this one, escarpment, because this is the wind, no, upwind, downwind. Then uh, our building is considered as downwind. So this is important because it has a factors later, as you can see. So let's try solving this one on how we get uh, downwind, or the, sorry, the topographic factor. So you can see here, this is the thing that we have discussed earlier, sorry. Okay. So I assume exposure C. So we're really not sure if it is B, or if it is D, no? So we assume exposure C. So And we assume that the height of the building is 18 meters. Okay, the peak is 1,403 minus 972 meters. That is 431 meters. So peak, so the distance, so this is the altitude and this is the distance. So the distance is 2040 minus 1050. That is 990 meters. And the building minus peak distance also is 600 meters. So H over LH. So it's okay. So the number 4 condition is satisfied that the H over LH is greater than zero point 0.2. So K1 per H over LH, you can see here. I will give you the no. So this one, okay, I will show you here. This. So escarpments to the escarpments, the second, so 0.85. Okay, exposure category C and escarpments to the escarpments here. As you can see here, to the escarpments, no? That is 0.85. To the escarpments and C. Okay. So to the escarpments and exposure category C give us K1 per HLH 0.85. So to get the K1, we just multiply point we'll just need to multiply 0.85 by H over LH, that is 0.4354. So we get 0.37. So we have the first multiplier K1. For the second multiplier, we need to get mu and gamma. So where should we get this mu and gamma? So gamma is just 2.5 for 2D escarpments. For ridge and axis symmetrical hill, that is 3 and 4 respectively. But for escarpments, that is 2.5. And for mu, no? Since this is downwind, like I discussed earlier, that downwind is where the location of our building, or it is at the back of the peak. So we consider 4. So for others, it's just 1.5. As you can see here. Then computing it, we get for the second multiplier 0.848. So for our next, for our last multiplier K3, 0.959, as you can see here. This is just simple mathematics. So we get 0.956. So getting our final topography factor or topographic factor with this formula, we get KZT is equals to 1.69. So as you can see, it is amplified for almost 69%. No? Instead of 1, the effect of the topography or the effect of the speed, wind up speed, no, or speed up wind, sorry. So because there is a phenomenon called, you can see here, speed up. Okay. Speed up of wind. Then instead of using 1.0 as a factor only, uh, the wind load will increase. So it will increase by 1.69, or the factor is becomes 1.69 instead of 1.0. So I have here some Excel in which we could try to, so let's go back to our data here. So let's try to input this data. If you can see the data here. Okay. Then let's try to input the data. So the building is 2640, 2040, 1050, and the location of foot is 90 meters from the original reference. So if we make the building as a reference here as 0, then this is the the new location. So the altitude is 1337. So the building is in 1337 meters. The peak is 1403 meters. The mid height is 1187 meters, and 972 is the foot. So as you can see here, if we try to change this one, it will also change the KZT. As you can see, if we compare the different diagrams of hill shape, to the escarpment gives us almost, so as you can see here, if we consider, so I will discuss this first. As the height increases, or as the height of the building increases, the factor decreases, no? So you can see here, there is a negative or downward trend. So as the height increases, the KZT decreases. So that is ano. So if I change the exposure category, so if I change the exposure category B, the KZT will also decrease. So as you can see here, the C, it's 1.72, but the B or the boy, it's 1.62, like the discussion of surface roughness. So if it is D, then obviously it will give us higher. It's almost double. The topographic effect almost double if the exposure is D. So if you have an escarpment near, let's say, coastline or shores or near the sea, then expect that you have higher wind loading there. So topographic effects and exposure category should really never be underestimated. It is really a part of wind loading. In any procedure, because there is so many procedures, there are two procedures: envelope, simplified, simplified envelope, or simplified directional. So directional procedure, uh, topographic effects and category exposure category, very important. So let's go back to C and let's try to compare this different hill shape. For 2D ridges, it give us higher. For 2D escarpments, it give us in the middle, but in the 3D, it give us much more uh, lower. So we can consider it as a 3D axis symmetrical hill, but for the purposes of this, let's just consider it as escarpment or ridge. So these are the examples. So these are the meaning, here. So let's try to compare it if what is higher, the downwind or the upwind. So downwind, so upwind give us a lower KZT compared to the upwind. Okay, so that is one of the examples of topographic factors. So I think this is the, I don't need to discuss anymore. So thank you.